In this video, we'll explore how to work with DWG and DXF files in Softree's terrain module. These two formats are quite similar, and for the purposes of this demonstration, we'll use them interchangeably. DWG and DXF are widely used formats, but they can vary significantly in terms of the data they contain and how that data is structured. This variability can sometimes make them less efficient to work with compared to other formats. The goal of this video is to provide you with practical workflows and tips to help you work with these formats more effectively. Over the course of the video, we will explore a variety of examples. Let's start with a simple one. To begin our example, I'm going to open the terrain module. We'll click the Insert File button and browse to select our DXF file. Reminder, this same process applies to DWGs too. In the Import Options dialog, I'm enabling the Create 3D Model checkbox, then clicking Continue. Right away, we see the linework has been imported, and the surface is automatically defined. That's a quick and easy start. Now let's take a step back and try importing the same data again, but this time with the Create 3D Model option turned off. Now, we can see the triangles that are defined in this particular DXF file, but since the 3D model option was disabled, we do not yet have a surface. We are going to discuss creating surfaces in more detail over the next few examples. In terrain, surfaces are defined using features called triangles. Not every DWG or DXF file includes triangles. In fact, it's fairly uncommon, but even without them, we can still bring in the data and work with it. Next, I'll delete the current model and import our second example. This is another version of that same file, but this one doesn't contain any triangle faces. So I've left the Create 3D Surface option unchecked. As expected, when we bring it in, there are no faces and no surface. But that's not a problem. We can easily generate a surface from this data. I'll do it without adding contours for now. From the Terrain Modeling ribbon tab, we select Generate Tin. And with just a few clicks, the surface is created. In order to generate a surface from a DWG or a DXF, the key element needed in the file are elevations. In many DWG and DXF files, there are lots of elements with zero defined elevation. We will discuss these in detail in another upcoming example. At this stage, the DWG or DXF features haven't been assigned any properties that define how they interact with the terrain model. Fortunately, we can adjust those quickly. For instance, if we want to tag all features named breakline, we can select them by feature name or by layer. Once selected, we simply enable the breakline property. We won't dive into the specifics of each property here, that's covered in other videos focused on terrain features and their behavior. But in this case, enabling the breakline property ensures that triangles don't cross the feature. And if we want every feature in the file to act as a breakline, we can turn that on, and just like that, we've got a clean, well-defined surface. Example 3. Importing contour data from a DXF file. In this example, we're going to import a DXF file that contains contour data. Typically, we recommend using other formats for surface data when available, because defining a surface from contours isn't ideal. The main limitation is that there's no survey data between the contour lines to accurately define the terrain. However, if contours are all you have, or there's a specific reason to use them, it's still a workable option. I'll bring in the file now. As it loads, we can see the contour lines clearly, and they're being modeled. Using these contours, we can create a tin model. To do so, select the Terrain Modeling ribbon, then Create Tin option. Here in this dialog, make sure to disable the Create Contours options. In the 3D view, we can explore our model. If we zoom in, you'll notice some artificial flat spots. That's a common side effect of working with contours alone. Since there's no data between the lines, the surface may not reflect the true terrain. One other thing to note, while this file isn't large in terms of features or modeled points, working with contour data can be relatively heavy in terms of performance. When working with DWG or DXF files, keep in mind they're often heavier formats. If you're using them to define a surface, that's totally fine, but they can impact drawing performance. For example, as I pan around here, you'll notice a bit of lag due to the density of the data being rendered. If your goal is simply to use the contours to define the surface, without needing them visible, you can select all the contour features and turn off their display properties. That way, the surface remains intact, but your drawing performance improves. Now, if you still want to visualize contours but in a lighter, more manageable way, you can generate your own. Just go up to the contour settings, turn them on, and choose a wider spacing. These contours are purely visual. They don't define the surface, so you get a clean view without the lag. Another situation where DXF or DWG files can feel heavier than expected is when they contain a lot of visual information, and labels are a prime example. Let's take a look at this small, simple DXF. As we zoom in, you'll notice it's packed with labels. While helpful in some contexts, they can quickly clutter the view and, like other dense features, consume extra resources during rendering. If we want to clean this up, we can easily turn off the labels. There are a few ways to do this, but here's a quick method. Select all features. Right-click, Modify Selected Features, then Modify Labels. Then we can turn off the DXF label display. And just like that, the labels are gone, making the workspace much easier to navigate. In our next example, we will look at cleaning up unwanted features. We are going to open a simplified version of that same file. No labels, no triangles, but it has a bunch of symbols. At first glance, it looks like a bunch of symbols, but these are actually imported as features. If we switch to the 3D view, we can see what happens if we try to model everything as is. For example, if I convert these symbols into break lines and then calculate our tin model. First, we probably don't want to see them. Second, we definitely don't want to model them. To clean this up, we can filter and remove them efficiently. Use Select Features either by layer or name. I'll use name this time for variety. We can select all features that start with a specific prefix, like 0. Then, either turn off their display and model properties, or delete them entirely. Once that's done, we click Generate Tin to rebuild our tin surface. Now we are left with a much cleaner, more efficient model. Sometimes, when we bring in a DXF or DWG file, symbols appear as features, and that's usually because they were imported as blocks. But we can avoid that entirely by adjusting the import settings. Let me show you. If we re-import the same file and simply turn blocks off, those symbols no longer come in as features. Instead, they remain lightweight visual elements, much easier to work with. No need to manually select features, turn off display properties, or delete anything. One of the more common issues when working with DXF or DWG files is mixing 2D and 3D data, especially in contour files that also include spot heights or other reference points. Let's walk through an example. In a fresh terrain, I will bring in a contour file that also contains additional point data. As we zoom in, you'll notice it's quite dense, and again, we don't need all those labels. To clean up the view, we can turn labels off globally, or selectively disable specific types. Now, switching to the 3D view before modeling, we can spot the issue. The contours are correctly positioned at elevation. For example, this one is at 112 meters, but the spot height down here is sitting at 0 elevation. Even though the label shows the correct value, the feature itself isn't anchored at the right elevation. If we model the surface without addressing this, we'll end up with undesirable spikes, where the surface tries to connect elevated contours with flat 2D points. To fix this, we could manually select features by layer or name, but a more efficient method is to select by range, specifically by elevation, z-value. Here's how. Use Select by range. Set the z-value range from -1 to +1, to capture anything at or near 0. Optionally include hidden features or retain currently selected ones. Once selected, we have a few options. Delete the features if they're no longer needed. Turn off display if we don't want to see them. Turn off modeled property to exclude them from the surface calculation. In this case, I'll turn off both the modeled and elevation properties. After recalculating the tin, those low elevation points are no longer used, and the surface is clean, without any pits or spikes. That brings us to the end of this overview video on working with DWG and DXF files in RoadEng. We looked at several common scenarios, from importing line work and contours, to cleaning up unwanted features in the terrain module. Stay tuned for a follow-up video, where we'll explore a few additional techniques and edge cases to help you get even more out of these formats. Thanks for watching, and be sure to subscribe for more RoadEng content in the future.